So when we talk about average rate of change, we're probably thinking slope. And you are absolutely correct, because that's exactly what we are talking about. When you have a linear function, go ahead and you calculate slope. But as we can see here with this parabola, that many functions are curved, so there is no slope. Curved. That's okay. Totally fine to go ahead and have no constant slope on there. But what we can do is that we can go ahead and pick an interval. So for us, we would say from A to B, and we would calculate the slope through the line that goes through these points. And this line right here that goes through the points is called a secant line. So instead, we calculate the average rate of change, aka the slope of the line, we should say secant line, passing through an interval. So for this one, we're talking about the interval from A to B. So what we say is the slope of the secant line is equal to f of b minus f of a all over b minus a. And yes, that looks all confusing. I get it. Totally fine. But it's just slope. Change in y over change in x, right? You probably saw it as y2 minus y1 over over x minus x. We're just talking about it in terms of function notation here, so we're talking about f of b minus f of a. So when we talk about it, let's go ahead and we're saying, hey, we have this function here and we're given the interval of, here of -2 to -1, and we're looking at the function f of x, which is negative x cubed plus 3x. So let's go ahead and let's calculate the average rate of change. So the first thing that we need to do is find f of -2. We're going to go ahead and plug that in. So -2 cubed plus 3 times -2. That's going to be -8 times negative, so it's positive 8 minus 6, 2. Okay? And then we're going to go ahead and calculate f of -1. Again, just plugging it in here. So we have -1 cubed plus 3 times -1. That's going to go ahead and give us positive 1 minus 3, which is -2. Okay, so there is my, if we're thinking about the top part of this, right? So the top part of the average rate of change is going to be f of -2 minus f of -1 all over, we're going to have -2 minus -1. And it doesn't matter which order that you go in, as long as you go in the same way. So we have 2 minus -2 all over -2 minus -1 is equal to 4 over -2 plus 1, which is equal to 4 over -1, -4. So what we say here, how we answer this question is the average rate of change, and you can use AROC as an acronym, of f of x over the interval of -2, -1 is -4. So that's your answer here. I'll go ahead and highlight it. Awesome. So again, it's just calculating the slope, right? Finding your outputs, putting it over your inputs. And when we're talking about these functions, we can talk about it in terms of different types of points and extrema, and just kind of some vocab here to go over. You can have a function that's increasing, as you see right here, right? This function's increasing. This happens to be like constant on this, but you could definitely have a curve. For example, it's increasing here, it's increasing here. So we, of course, can increase. And when we're talking about increasing, we're going to talk about it in terms of the interval. I'm going to say from negative infinity to -5, but I'm never going to include the -5. At -5, we cannot say whether it's increasing or constant. So you want to make sure that you put parentheses there. It's going to be constant over the interval of -5 to 0, and it's decreasing over the interval of 0 to infinity. And again, it's just looking for this intervals, kind of using that interval notation that we worked with earlier in terms of your graph and describing your graph. Now it's also going to go ahead, we're going to be looking at graphs, and we're going to be looking at whether it has a minimum. So this right here is called a local min, whereas this one down here is called an absolute minimum, and that's because it is the absolute minimum of this function. Whereas right here, it's the minimum part of the function between this interval right here, right? That's as low as it gets here, but this is where it absolutely gets to the lowest. And then this, of course, is called a maximum, or what you might call a local maximum, because it keeps going up farther than that point. And you kind of see it here on the other picture, is that we have a maximum in this situation and a minimum, but what we also see is called a point of inflection. And point of inflection is where it switches, so where it switches from what we call concave or concavity. And that's basically saying where it's up to down or down to up, right? So concavity is all about whether you have like something that's going up or down. We talk a lot about this in terms of parabolas. An upward facing parabola, we're now going to use the word concavity. So why don't you go ahead and grab your graph and calculator, and we're going to definitely be going over how to find this on your calculator. But for our video purposes, I'm going to give you our answers here. So you have a minimum at 2.155 of -4.079, and you have a maximum at -0.155 of 2.079. And as a reminder on our in behavior, I'm going to say the limit of y as x approaches infinity is infinity, and the limit of y as x approaches negative infinity is negative infinity, just as a reminder on those. Okay, so let's talk about average rate of change of a certain function over some intervals. So when we're looking at this, I put the graph up here, and we can actually just look at the graph and calculate your average rate of change, aka calculate the slope between these secant lines right here. So I'm going to start with this one, and as you can see, the slope of this line, if you're counting, right, is going to be -7. And I simply just got there by going down 1, 2, 3, 4, 5, 6, 7 to the right one. All right, and then we're going to keep calculating these secant lines, the slopes of these secant lines. This one going down 1, 2, 3, 4, 5 to the right one, so -5. And I'm going to draw a few more here. So this is -3. And our last one down here, -1. And then you'll notice we're going up here. This is now +1. think I'm repeating colors, but that's okay. This is positive 3. And then we go positive 5. And for your last one, we have positive 7. So there's a whole bunch of really cool things that we kind of dive into in terms of your average rate of change of this quadratic. But the main thing that I want to go ahead and kind of point out here is that at this point, right here, your average rate of change goes from negative to positive. Goes from negative to positive. So in terms of looking at the function, we can obviously look at this function here and we can say, well, this function is concave up, or what we have referred to in the past of it's facing up. Now, looking at this in terms of our rate of change, we're saying the rate of change is getting less negative, and all of a sudden it switches to positive. And at that switch, that's how we know this is concave up. So what we could say is that we might not know what the function is if we were just given this piece of information, only the interval and the average rate of change. Is that from looking at the intervals and the average rate of change, we can say that it's concave up over the interval of -4 to 5. Right? We can say that it's concave up over that interval. Now, obviously, we can also look at our function here and figure it out, but that's just kind of how we are defining concavity in this situation. All right, the last thing that we're going to be looking at is kind of this average rate of change. Now, if you take the difference of these, you're going to notice something really, really cool, and we're going to be working on that in class. But for purposes right here of our video notes, this is what we're discovering today, is that your average rate of change, and again, I'm going to write that down, average rate of change of a quadratic is linear. So basically meaning if you take the difference between all these, you are going to get kind of a linear function in terms of that. And then also, if you take the second average rate of change, right, if you take the difference of those again, then you get a constant. And we know that from the fact that a linear function has a constant average rate of change, right? That's what makes a linear function a linear function. It does have a constant rate of change. All right, so second last bit of notes that you should know is that, of course, we are using the word concavity, aka it's going to be either concave up or concave down. So we want to get used to that kind of vocabulary there. We're just going to go ahead and highlight it for you, concavity.